everyone, welcome back. Glad to see you again. So in this part, I will be discussing about one of the important topic for any competitive examination, that is your chemical preparation or chemical properties of your amines, right? So will be discussing about different reactions, and in this part we will be discussing about the reactions of aniline, and the reactions of aniline, especially the diazonam salt concepts, is very important for IIT-JEE mains and advanced also, and even the questions are asked in AIPMT also. So why to waste our time? Let's start with this part. Chemical properties of your amines. So the first important thing is that we'll discuss about what happens when 1 degree amines react with HNO2. The first important chemical property of amines is the reaction with HNO2. So what happens when amines react with HNO2, that too 1 degree amines. So 1 degree aliphatic amines, they give a mixture of unarranged and rearranged substitution and elimination products, all of which are produced by way of a diazonam ion, and it loses what nitrogen to give carbocation. What is a diazonam ion? First we have to understand this. Any Rn2 plus or Arn2 plus ion is actually your diazonam ion. So aromatic diazonam ions are more stable than your aliphatic or aliphatic ones. So now what is a diazonam ion? For example, you have this Rn2 plus is actually your aromatic diazonam, and if you have CH3 CS2 N2 plus or Rn2 plus, this is your aliphatic diazonam. So now second degree amines with HNO2, reaction of secondary amine, it gives an nitrosamine. Just like your 1 degree amine, there is loss of nitrogen and you will be getting carbocation. A 2 degree amine, it gives an nitrosamine. So what is the step 1? The step 1 of this process is that the reaction of 2 degree amine with the nitrosyl cation, which is an electrophile. So the first step, what happens is that reaction of secondary amine, which is a nucleophile, right, that reaction takes place with a nitrosyl cation, which is an electrophile. Step 2, it is the proton transfer. The proton gets transferred. For example, we can see here now you have 2 degree amine. So that 2 degree amine in reaction with nitrosyl cation, this is a nitrosyl cation. So what happens is that this nitrosyl cation actually gets attached here, and after that what happens is proton transfer takes place. So after proton transfer takes place, you will get this kind of structure. So you can see that hydrogen is actually donated in terms of a proton, in the form of proton, and you will get this kind of structure, and this is formed as a result of a proton transfer. Tertiary amines with HNO2, tertiary aliphatic amines, right, they are water soluble or water insoluble. Either they are water soluble or either water insoluble, they are protonated to form water soluble salts. Next, tertiary aromatic amines, since NO plus is a weak electrophile, so you know that NO plus is a electrophile, but it is a weak electrophile, and it precipitates in EAS. What is EAS? Electrophilic aromatic substitution. So 2 degree aliphatic and aromatic amines, they react with your electrophile to give n nitrosamines. So for example, piperidine. So what happens when piperidine reacts with HNO2? You will get n, n nitrosopiperidine, right, because your NO plus is an electrophile which is getting attached to your piperidine. Next, 1 degree amines with HNO2, formation of diazonam ion is the step 1. The step 1 is a reaction of 1 degree amine with your electrophile, which is NO plus. So if I have 1 degree aliphatic amine with this electrophile, you will get a nitrosamine, and afterwards ketoenol tautomerism takes place and you will get a diazetic acid. So protonation is followed by loss of water. This is important, right? You know that protonation is always followed by loss of water. That means I have a diazetic acid, I have in presence of acidic medium. What happens? Then proton gets added. So once proton gets added, then removal of water molecule takes place, you will get a diazonam ion, and afterwards this diazonam ion can be converted into a carbocation and N2. So what is the final product? It is a carbocation and N2. So aliphatic diazonam ions are unstable and lose N2 to give a carbocation. So which may lose a proton to give an alkene, further which may react with a nucleophile to give a substitution product, which may rearrange and react by 1 or 2. So you can see that if you have an alkene, NH2 which is attached to an alkene in presence of NaNO2 and HCl, right? Remember, this is NaNO2 and HCl, or HNO2 is the same reagent. So you may get chloride attached here. Chlorine may get substituted, or you will get alcohol, or you may get set of your alkenes. So the N2 group of a diazonam salt can be replaced in a regioselective manner by these groups. That means the aromatic diazonam salt is more stable than your aliphatic due to resonance. This is another important point. The aromatic diazonam salt is more stable. This is more stable than your aliphatic diamines. It's because of resonance. So you can see here aromatic. So I'll be explaining about this in detail, right, when I discuss about your aniline and its reaction with H2O, its reaction is HBF4, HCl, HBr, KCN, Ki, H3PO2. I'll be discussing in detail in the subsequent slide. So if you have 1 degree aromatic amine in presence of HNO2, as I already told, this is converted into alcohol, because after carbocation is formed, as I already told you, will get a carbocation. After carbocation is formed and hydrolysis, that forms an alcohol. Right, so 2-bromo-4 methyl aniline gives 2-bromo-4 methyl phenol. So problem. There is a problem here. What reagents and experimental conditions will bring about the conversion? For example, you have CS3. I should convert into CS3NO2. CS3NO2 will convert into COOH and O2. Then it converts into COOH NH2, COOH and OH. So the important concept is that you can see here you have a methyl group and finally it can be converted into COOH and OH. That is the beauty of reaction of your amines or aniline. For example, 1 degree aniline with HNO2. So this problem, the solution for this problem is, right, it's just after few slides. Similarly, this is also the same thing. If you have, just keep this in mind, okay? Just keep this problem in mind. You have to understand how this can be converted into this, how NH2 can be converted into chlorine, it can be converted into cyanide, it can be converted into CS2NH2. Not only that, substitution. So for all these are the reaction of your, all these are the diazonam reactions which I will be discussing soon. So next, Hofmann elimination. Hofmann elimination is again nothing but the thermal decomposition of quaternary ammonium hydroxide to give an alkane. So the step 1 is the formation of 4 degree ammonium hydroxide. So step 2 is the thermal decomposition of the 4 degree ammonium hydroxide. So for example, you have cyclohexamethyl or trimethyl ammonium hydroxide in presence of your OH minus at 160 degrees will get methylene cyclohexane, and not only that, a trimethylamine and H2O. So Hoffman, obviously, can I say now? Hoffman elimination regioselective, yes, and the major product is your least substituted alkene. So this is what happening if we have a tertiary amine and heating it, you will get an alkene, and not only that, you will get CS3 triacen and H2O. So Hoffman's rule, any elimination, this is very important, any elimination that occurs preferentially to give the least substituted alkene as a major product is said to be your Hoffman's rule. So you can see here the same set of your amines undergoes E2 reaction here, right? Because it's a regioselective again. So it gives, there is proton transfer and you'll be getting an alkene. The regioselectivity of Hoffman elimination is determined largely because of steric factors, namely the bulk of your NR3 plus group. So hydroxide ion is preferentially, it approaches and removes the least hindered hydrogen and it gives the least substituted alkene. So this is an important point, right? Because you have hydroxide ion, it preferentially approaches and removes the least hindered hydrogen. So least hindered hydrogen is removed and gives the least substituted alkene. Once you have bulky bases like your CS3 tri-CO, right, they largely give your Hoffman elimination. So Hoffman elimination with your haloalkanes. This is also an important point. Cope elimination. This is also one of the important chemical reaction of your amines. So cope elimination is actually thermal decomposition of amine oxide. Step 1 is the oxidation of 3-degree amine. It gives an amine oxide. So amine in presence of H2O2 will get amine oxide. So oxidation of 3-degree amine, it gives an amine oxide. This is step 1. So step 2, if the amine oxide has at least one hydrogen, it undergoes thermal decomposition to give an alkene. So afterwards, immediately after thermal decomposition, you will be getting an alkene. So cope elimination shows syn stereoselectivity, but remember this stereoselectivity is little or no regioselectivity. So it's a mechanism. So after a transition state of your amine, right, if you are heating it, you will be getting an alkene, and not only that, N, N dimethyl hydroxylamine. Next, very important for any competitive examination, the diazonam salt, the one which I was waiting for, and the one which I am actually making you guys to wait for. So primary aromatic amine is treated with nitrous acid. This is your nitrous acid. In a cool solution, product is unstable compound, which is diazonam salt. This is actually an unstable compound. Remember, this is unstable compound, and this is also called your diazonam salt. And this whole reaction is called diazotization. So your primary aromatic amine converting into your diazonam salt is diazotization. So this is the nature, or this is the structure of your diazonam salt, right? So it is again like ArN2 plus, which I already told you, and X minus. So what is the mechanism of diazotization? Again important. You have NH2 and you have NO, which is an electrophile. It attacks this NH2, and after that you will get NHNO. Afterwards, fast rearrangement takes place and you will be getting NNOH. Afterwards, you will be getting N2 plus. So The reactions of diazonam salts are very important. They follow this process. So in any reaction of diazonam salt, first your aniline is converted into diazonam salt with the help of your HNO2 or NaNO2 in presence of HCl. So these salts actually give substitution reactions and coupling reactions. So what are the substitution reactions which are possible? The substitution reactions which are possible are, if you have your diazonam chloride, that diazonam chloride first in presence of H3PO3. In presence of H3PO3, you will be getting benzene and nitrogen, and after that, after reacting with H2O, you will get an alcohol. So here especially phenol. So let's write, you will get a benzene, you will get a phenol. Next, in presence of CuCl or HCl, which is a Sandmeyer reaction, CuBr HBr, you will get an aryl halide. With copper powder, HCl, copper powder HBr, you will get again aryl halide. But this is a Sandmeyer reaction. When you are reacting in presence of CuCl and HCl, this is actually Gattermann reaction where you are reacting with Cu powder and HCl. Next, Ki, again an aryl halide, but it is for iodine. So for iodine you have to need Ki. Next, HbF4 is Balch-Schimann reaction, again an aryl halide. Next, KCN, you will get a cyanide, and you know that cyanides on hydrolysis gives acid. So you will get an acid benzoic acid. And not only that, what you can get is, you can get a coupling possible. So you can have a coupling where your two benzene rings get attached with each other. These are the different substitution reactions of your diazonam salt. So what is a coupling reaction? Coupling reactions are the electrophilic substitution reactions. So what is happening is that you have your diazonam salt. The diazonam salt in presence of any such group where Z is an activating group, you will get both nitrogen and nitrogen at the center, and you have both rings with Z present here. This is a coupling reaction. Examples of the coupling reactions. So these are the following examples. So you can see here the salt, diazonam salt, benzene diazonam chloride in presence of phenol. Now we have Z, which is an activating group, is actually phenol. In presence of weakly alkaline nature, you will get para-hydroxybenzene. This is a coupling reaction. In presence of aniline, again a coupling reaction, right, where you have para-aminobenzene, right. So in the same way, if you have NO2 here attached, NO2 here and NO2 here, and if you have anisole, again a coupling reaction. Remember, for coupling reaction, this Z should be an activating group. Z should be an activating group. So you have your diazonam salt, you have again an activating group, you will get methyl orange. So what is this methyl orange? Methyl orange is an indicator which is used in your chemistry laboratory. So this methyl orange, which is an indicator, is formed because of coupling reaction. Next, Hinsberg test. Let's now analyze amines. What is analysis of amines? In analysis of amines, we will be actually performing different tests. So the first test is Hinsberg test. So what is this test? This is actually the test to distinguish between 1 degree, 2 degree and 3 degree amines. So the Hinsberg reagent is benzene sulfonyl chloride. So this is benzene sulfonyl chloride, which is actually a Hinsberg reagent. So this Hinsberg reagent reacts with RNS2, you will get N-alkyl benzene sulfonamide, and as a base which is soluble. So again the same thing, you have a 1 degree amine, RNS2, you have a 2 degree amine, you have, with the 1 degree amine, you have a soluble base, but if you have a 2 degree amine, you will get an insoluble base. In a 3 degree amine, there is no reaction. So this is how you can differentiate your 1 degree, 2 degree and 3 degree amines. Next, last important test is your isocyanide test. What is isocyanide test? This test is actually distinguish 1 degree, 2 degree and 3 degree amines. This test is given both by 1 degree aliphatic amine and 1 degree aromatic amine. So if we have 1 degree aromatic amine and if you have 1 degree aliphatic amine, both gives a positive test with the carbonyl test. That means your RNS2CHCl3KOH, you will get alkyl isocyanide, which is unpleasant smell, right? So remember, here also this test is given by your 1 degree aliphatic amine and 1 degree aromatic amine. So you have 1 degree amine converted into your isocyanide, alkyl isocyanide, which is unpleasant smell. So as soon as you get this unpleasant smell, you can say that this is actually a 1 degree amine. Similarly, your aromatic amine in presence of CHCl3KOH, you will get an isocyanide. So now with the help of this carbonyl test and Innsbruck test, you can differentiate your 1 degree, 2 degree and 3 degree amine. So these are the different chemical reactions of your amines. So guys, so these are the different chemical reactions of your amines, right? Either 1 degree amine, 2 degree amine, 3 degree amine, and also your properties of aniline. We have discussed about different chemical tests of your amines also. So this is one of the important topic I am saying once again. So in our next part, I will be discussing about previous JEE questions. Till then, stay tuned. Take care.